now we have an example of how to figure out how much our payment should be if we want to accumulate a certain amount. So computation of rent here, we've got an example. We've got, assume that you plan to accumulate $14,000 for a down payment on a condo 5 years from now. So this is a practical application. You want to buy a house. You want to accumulate at least a certain amount of money for a down payment at some point in the future. So for the next 5 years, you earn an annual return of 8% that is compounded semi-annually. How much should you deposit at the end of each 6-month period? So now we don't know what the we do not know what the rents are, but we know that we can find out what the future value factor is. So let's take a look at our table here, and we have, so it doesn't really matter what we're putting down right now, but I'll write that down. 14,000. So we've got 5 years, 2 times a year, right, at 8%. So we're going to take this, our periods, 5 times 2, 10. Interest is 8 divided by 2, 4. Okay, so we've got that information. Now we're going to take our 10 periods and 4%. So our factor is 12.00611. Okay, so that's step 1. We've figured out what our future value factor is. All right, so, and I think, let's see here. They've got here. So our future value factor is 12.0611. We can use that. Then we have to, in this case, we're going to do a little bit of division. Okay, so what we have to do at this point, we're going to take the amount that we want to save, divide it by our factor. And this is going to be the amount that we need to save every month, or each one of those periods. So 14,000 divided by 12.00611, 1166.07 is how much we want to save. Still can't see that. Here we go. Okay, so let's take a look at the rest of the problem here. So we're back to this. We figured out our factor, the 12.006. So R, and we did this. So remember, this is the formula. The future value of an ordinary annuity equals R, rents, times the future value factor. So using algebra, we are going to, in order to solve for R, we just take the 12.006 and use that as our denominator over on the other side. So 14,000 divided by 12.006, R equals 1166.07. Okay. So this is what this is where we found this. 14,000 divided by the 12.006 is 1166. Okay, so let's do, I guess that's the only example. No, they've given us another example. Okay, so let's go through that one. Okay, so computation of the number of periodic rents. So now, before we didn't know how much, we knew how long we had, but we didn't know how much we were supposed to save every month. Now, we know what our periodic deposits are going to be, or we know how much our rents are going to be, the $20,000, but we don't know how many deposits we need to make. So here's, suppose that a company's goal is to accumulate $117,332, making deposits of $20,000 at the end of each year, and so that's why we've got an ordinary annuity. This will earn 8% compounded annually while accumulating. how many deposits must it make? All right, so again, we've got 117,332 and 20,000 are our rents and 8%. But we don't know how many rents to make. So what we have to do is, here's our equation, 117, and again, we're just solving for this factor. So we're going to divide the 117,332 by the 20,000. We're going to solve that with algebra. So 117,332. Let's see here. Divided by 20. So 5.8666 is our factor. All right, so now we know that that's our factor. I think they're going to give that to us. 5.8666, yes. Okay, so now we have to use the table to find the number of periods. So let's go back to our table. So here's our factor. And we are at, whoops, I think we need to fold this over because we're at 8%. All right, so we're at 8% here. And we just scroll down till we find a factor that is close to that. So we come down. Oh, there it is. 5 periods. So we need to save $20,000 at 8%, $20,000 for 5 periods at 8% in order to accumulate $117,332. Okay? All right, and then so I'm going to leave this this lecture at this point. And then we're going to look, and the next one, we're going to look at the future value of an annuity due. These have been ordinary annuities that we were kind of playing with here. We're going to look at the next one will be the future value of an annuity due, which uses a different table. Still one at the back of your chapter though.